Hi, my name is Mr. Chu and you're welcome to my study room. If this is your first time, then I want to encourage you to subscribe to this channel for more videos. Today's study is about the condition for tangency of a circle. This lesson is just asking a simple question. How do you determine if a straight line is a tangent to a circle or not? And in this lesson, I'm going to use two methods to determine whether a line is a tangent to a circle or not without drawing the line and the circle. For calculation purposes, a line is said to be a tangent to a circle if the perpendicular distance drawn from the line to the center of the circle is equal to the radius of the circle. Let me just draw a circle quickly to explain this point further. Alright, so all we are saying is that if this is a circle and this is a tangent to the circle, then at the point of tangency here, when you are given the equation of this circle and then you are given the equation of this line, for you to determine whether this line is a tangent to this circle, you first of all find the center of the circle from the equation given. After finding the center of the circle, you also calculate for the radius of the circle. After calculating for the radius of the circle, you now come to calculate for the distance from the center of this circle to this line to determine whether it is equal to the radius of the circle. And when I say the distance, I mean the perpendicular distance. You calculate the perpendicular distance from the center of this circle to this line. If it is equal to the radius you've got, then you can conclude that this line is a tangent to the circle. So if you are given the equation of this line as just the general equation of a line, ax plus by plus c equals 0, and the center of our circle is a and b are here already, so let me use mn. The coordinate of the center of our circle is mn. Then the perpendicular distance from this line to the center of the circle, which we would like to call d in this case, will be equal to the absolute value of a m plus b n plus c all over the square root of a squared plus b squared. That's like I said, absolute value. So this is going to give us the perpendicular distance from the center of the circle to the line when you are given the equation of both the line and the circle. Though I've said all already, let me just try it quickly for those who would like to note it. We have our steps here. The first point says calculate for the center. In this case, because our line already has the equation a and b in its equation, I decided not to use a and b as coordinate of the center again. So I says calculate for the center of the circle with coordinate mn and radius r of the circle. I have a number of videos on how to calculate for the radius of a circle. Then the point 2 says using the center of the circle mn and the equation of the line, which is in the general form ax plus by plus c equals 0, find the perpendicular distance d using the formula d equals am plus bn plus c all over square root of a squared plus b squared. And this is what we did to get this equation. We wrote the equation of the line, then wherever we see x, we substitute the x coordinate of the center of the circle there, and wherever we see y, we substitute the y coordinate of the center of the circle there, all over the square root of the a here is just the coefficient of x, and the b here is the coefficient of y. And then we did that to find the absolute value, means that we are only interested in a positive answer. We calculated for the radius here. After getting d, we check if they are the same. Then we conclude that the line touches the circle, or here I'm saying the perpendicular distance. So we conclude that the line is a tangent to the circle. We take an example quickly to verify what we are saying, and then we use the second method to solve the same example for us to see that they have the same answer. Our example says determine whether or not the line 4y minus 3x plus 20 equal to 0 is a tangent to the circle x squared plus y squared minus 2x minus 4y minus 20 equals 0. We are going to find the center and radius of this circle first. Comparing with the general equation, our 2g is going to be equal to negative 2. Dividing 2 by 2, g will be equal to negative 1. And our 2f will be equal to negative 4. Dividing 2 by 2, our f is going to be negative 2. And the center of our circle is negative g, negative f. So that will give us 1, 2. Alright. Then now we find the radius of the circle, which I already have a video on. So we are just going straight to use the formula r equals the square root of g squared plus f squared minus c. And that is going to give us the square root of our g is negative 1 squared plus our f is negative 2 squared minus our c is the constant term in the equation of the circle. So that is negative 20. So this gives us the square root of 1 plus 4 plus 20. And that will give us square root of 25. And this is equal to 5 units. So this is the radius of our circle. Now we go back to get the equation of our line to find d. My x can still be negative and I'll work, but because I want to bring the x first, and for my x to be I don't want to bring negative x first, let me divide through by negative 1, and that's going to give me negative 4y plus 3x minus 20 equals 0. So rearrange, I'm going to have 3x minus 4y minus 20 equals 0. So now with this as the equation of my line and the center of my circle 1, 2, from the formula I gave that this is going to be our m and this is going to be our n. So our d is going to be equal to the absolute value of 3, our m is 1, minus 4, our n is 2, minus 20, all over the square root of 3 squared plus negative 4 squared, the absolute value of course. Working this further, you're going to have the absolute value of 3 minus 8 minus 20 all over the square root of 9 plus 16. This is going to give us negative 25 over, this is square root of 25 is 5. and then this should give us negative 25 over 5 is negative 5, and because you are looking for the absolute value, this is equal to 5 units. All right, so since our D equals 5 units and our R from here also equals to 5 units, then we can conclude that since the perpendicular distance from the center of the circle to the line equals the radius of the circle, then the line is a tangent to the circle. Let me just write that quickly. All right, so we conclude that since the perpendicular distance D is equal to the radius of the circle, it follows that the line 4y minus 3x plus 20 equal to 0 is a tangent to the circle with equation x squared plus y squared minus 2x minus 4y minus 20 equal to 0. So that is how to prove. Then I said earlier that I'm going to use two methods. In the second method, we are just going to use a substitution method to solve the two equations, the equation of the line and the circle, to obtain the values of x. If we get repeated values of x, then we conclude that the line is a tangent to the circle. And this is based on the fact that in finding the root of a quadratic equation, we say that for repeated roots, the curve only touches the circle like this. Calculation, and we have a repeated answer for x. It means that the line touches the circle and therefore qualifies to be the tangent of the circle. So let's use the same question to verify. Alright, so I've decided to call the equation of the line equation 1 and that of the circle equation 2. I'm going to use a substitution method just like I said earlier. From equation 1, y will be equal to 3x minus 20 all over 4, and I will decide to call this equation 3 so that I don't keep writing it. We put equation 3 into equation 2, and that will give us so let me quickly go through substituting equation 3 to equation 2. So wherever we see y, we substitute the y value there. So that's why we have y squared here, it is here, then 4y is also here, equal to 0. Then by using binomial expansion, this is going to give us 9x squared minus 120x plus 400 all over 16 minus 2x is here. Then this 4 will cancel this 4 here, so we have negative 1 opening this parenthesis, gives us negative 3x plus 20, then minus our 20 here. We multiply through by the 16 to get rid of the fraction, so that is what gives us 16x squared plus 9x squared minus 120x plus 400. Then adding these two give us negative 5x times the 16 will give us negative 80x. This and this gives us 0, so equal to 0. Then by simplifying further, this and this will give us 25x squared. Then this and this will give us 200x plus 400 equals 0. Then divide it through by 25. We are going to have x squared minus 8x plus 16 equals 0. Then we factorize. You can take your time to factorize. If not, I already have some videos on factorization as well. I can share the link at the top. So you factorize to get x minus 4, x minus 4, and x becomes 4 repeated. And like I said from the beginning, the repeated root shows that the circle only touches the line and not cuts through. So since we have a repeated root showing that the circle only touches the line, we can conclude that the line is a tangent to the circle. And this is where I would like us to bring today's lesson to an end. I hope it has been of help to you. If yes, why not consider subscribing to this channel for more videos like this and more. And I have other videos there too. You can just check through and work more. Till I meet you again in my study room. It's bye bye for now. Thank you.